Welcome. Hello, everyone. Welcome to another episode of BIM After Dark Live. This is episode 78, believe it or not, which is pretty wild to think about. I've got an awesome guest coming from over the sea, over in London. I can't wait to introduce him. We're going to be talking about some really fun and cool and interesting stuff. I'm sure you guys saw from reading the description. He's from Zaha Hadid Architects, but there's going to be some really cool and interesting conversations that I think will excite everyone. For those of you who are coming here for the first time, thank you so much for joining us. If you're live, thank you for joining us live. I will be checking out the chat the whole time. If this is your first time here, this is a weekly live stream where we talk about Revit, BIM, architecture, engineering, construction, and really just any related software about it. Really just kind of geek on about all that kind of stuff. So super fun. Like I said, episode 78, so we've been doing it for a while. And it looks like we've got a few folks from different parts of the world. It's kind of fun to do a little different time every once in a while and see who joins. So hopefully my European friends, hopefully this works for you. I know you guys are always upset that you can't join live at the normal time. So thanks for joining. And again, I will be checking out the chat. Awesome. So before we introduce our guest, I did want to take a moment to thank our sponsor for this episode, which is Twinmotion. For those of you that don't know what Twinmotion is, it is a real-time rendering engine built on the Unreal Engine. Hooks up to most software that you guys are using for modeling, as well as to Unreal as well, with a direct link and a few other pieces of information. If you've familiar with my channel at all, you've probably seen quite a bit of content that I produce on actually how to use it, but some great features came out with Twinmotion 2022, and I definitely urge you guys to check it out. I've been doing a weekly sort of highlight reel for Twinmotion. This week I'm not going to do it because we're going to be showing a little bit of it during the episode, so stay tuned for some of that. If you're interested in trying it out, head on over to twinmotion.com/BIMAfterDark. Sign up for a full working 2-week free trial so you can test it out, see all the awesome libraries, scans, images, all kinds of cool stuff you can make, and show them that you heard it here and you appreciate and support this show. All right, so I was just checking in there. We got a few new and few returning folks. How's it going? All right, so without further ado, I am going to introduce my guest because I do want to jump right into the content because we got some really cool stuff to show. And so with all of that, I do want to welcome to the show Cesar Fragachan. I know I butchered your last name, so I apologize, but welcome to the show, man.
Not at all. It was great. Thanks, Jeff. Really glad to be here.
I did my best. I was going to try to put on some accents and try it, but I can't do it. I just not even going to bother.
No, it's perfect, my friend. It's well better than a lot of people. Yeah.
So thank you, Cesar. Thank you for joining us. I appreciate you taking the time. And maybe before we jump into the content, if you don't mind just telling some folks here on the show who you are, what you do, a quick little bio of how we what we're going to talk about and why you're interested in it.
Absolutely. Thanks, Jeff. I'm Cesar, as Jeff introduced already. I worked at the Computational Design Group at Zaha Hadid Architects. I did my master degrees in the AA, the Architectural Association, under the Design Research Laboratory, specializing mostly on computational design and game technologies. So been quite keen on invest time in user participation and how people can, be part of the design process as well. So as architects, we tend to normally kind of lay out the rules ourselves, but what happens if we can program and code those rules so people can play with those? So that kind of led me a little bit of this line of research that we have been extending over in the Computational Design Group at CODE, at Zaha Hadid. So we've been working on interesting projects. One of the case studies that we can discuss today is a Configurator for Roatan in Honduras. And also very recently, we have been extending all of these because it applied very well also to concepts in metaverses and digital twins. So how we see ourselves as a little bit of software agnostic people. So we work with different frameworks and try to put together, different tools under the belt. So whatever we need to apply it, keep it agnostic and try to work with data out there. So very happy to be here at the show. I know most of the times, I mean, it's interesting just to discuss about other topics in, on other softwares.
Yeah, no, 100%. And I agree. I think, part of the reason this show is called BIM After Dark and not Revit After Dark is that, there's I'm not naive enough to say like Revit's the only program that exists, right? And fine. And there's also the ability to talk. And so it's interesting. And when you and I chatted before, the concept is really fascinating to me, and it's a lot of, I think we're trying to do the same things in different areas of the design build side of it, and it's really, we have all these gaming engines, we have all these virtual reality, mixed reality, augmented reality, Unreal, Twinmotion, you go down the list, right? All these things, and how do we make those valuable pieces of the current process, and then how do we use those to actually affect the angle? And I know a lot of people, when they initially see something like VR or Unreal, or even some of like the configurators you're going to show, they may be thinking, well, this is cool, it's kind of gimmicky though. How does this become real? And I love, when we first talked, even, the idea was, using these tools to actually not just engage clients and engage users, but also to affect the downstream, building and the design of that process. So I'm super excited to see. I've seen some previews of what you're going to show, so I get a sense of it. But I'm super excited for everyone here to also see it. And so maybe what we do is, I know you have a little bit of an intro sort of slide deck and then some case studies. Maybe we just start there. Whether you want to jump right into a case study or you want to lay the groundwork with the intro, and then from there we can kind of see where the conversation goes.
Absolutely, sounds great, Jeff. So yeah, let me kind of jump into it. So on generally on our workflows, we tried when in Zaha Hadid, we're very design oriented, right? So we try to make sure that all the outputs looks great, and then how can we curate those outcomes? This is like the project that I was mentioning in Roatán in Honduras. Mm-hmm. So at the beginning, we kind of set up a scene, and then Twinmotion in this case is where it really is great to set up something quickly and just to get a feel of how that place would be. So at the beginning, we don't really know how it's going to turn out. So this was like the hypothesis with this project, right? Like just trying to lay out some of the system design just to allow people to configure, but we needed to make sure that the mood that we take from the scene, it's curated enough for, to the standards of a Zaha design. So not only exteriors that we can control quickly with Twinmotion, we can also do all of these kind of scenes where you get real-time lighting, and people dynamics, just to get a feel of that user participation on how, at the end, that as architects, that's what it's really most exciting, right? Like constructing those spaces. Mm-hmm. And putting ourselves in different times of the day on how we can appreciate that the lighting conditions, and then this game engines and Twinmotion are being really, really pivotal on those early design studies. So these are really like some previews of how we show it up in those early design studies, just to make sure again that we're capturing the right intention. After we have the actual feel, we then break all of these into a kit of parts. And then, believe it or not, everything that you see here on the screen is just a kit of parts. Everything is modular. So that's what it becomes interesting. Then how can we interface it, and then how can we encode the rules to create not only like the communities, but also make it available on our configurator. And then all of what we extract from the configurator is data that we can bring back to software such as Rhino or Revit in this case. So that's why we try to keep it a little bit of agnostic on that sense. So we kind of lay out a little bit the system grid of that design intention, and then we voxelize all the space, all that initial. We kind of run analytics, environmental analysis, views analysis, and then how can circulation and different type of unit work, and then all of that it's mapped into different system grids, as we'd like to call it. So in that sense, we can really turn out and extract that geographical geolocation, and we can extrapolate it back again into our configurator. So we can jump a little bit on a live show of how that configurator looks and how people that are in this island are configuring their units. Let me actually share, because it's all also made with Unreal Engine, and then we can plug in. So this is a cloud hosted. It's running on a local server right now, running on my machine, but this is being deployed on the web. So I'm gonna put just Jeff. Let's make your unit, Jeff, in in real time. Yeah. So once we log in, I'm gonna have some instructions over here. So we jump directly into the scene. So this is what they're presented, potential buyers in this case, and then we can really adjust the scene very quickly, thanks to Unreal. And for example, the first thing that they can choose is where the users want to place their clusters, like their actual unit, and then they can see, for example, this is another building that is going to be on site, and then they can see like the views from that location in any given time. So whatever you see the sea, and people can start actually understanding the locate, like the distance to the sea, the views that they are getting with. So let's say we want to choose that location, then people can say, okay, I want my unit to be on one of the top of the stack. So let's select this one. Now I can start checking. Okay, I can choose between different types of unit, and then I can. This is a 75 square meter. This is a 150 square meter unit. Let's go with a wide one, maybe like 225. That sounds about right. And then you see, like, depending on it allows you, like, the system is intelligent enough that it shows you where you can place or where if you're off limit. So once we start saying, okay, now this one is I'm allowed to place here, and then it tells you already some data out of that position, right? It tells you what's the distance to the closest building, what's the distance to the road, what's the actual unit area, and the distance to the sea. So people want to have like a closer unit closer to the sea, they can also select that. And then once they place their unit, they can start also customizing air rights, right? Like when we do like this voxel, like the system grid, they can also say, okay, I want to buy air rights for future expansion. So I want to, no one we're going to be able to place above me. So I'm going to have my full terrace for me, or I can start adding some spaces on the sides. Let's say I want to have only on the left side because this side is clear, and I don't want any of my views being obstructed by anyone in front of me. So I buy all those air rights, and now I can get into the property, into the unit. So how then when we get inside, we can also customize there like the layouts, and then depending on whatever they select, let's say I'm gonna go with the first one, have some of the bedrooms facing towards the front. If they want to also fit the layout, they can do it such from here. And now once we get into the actual unit, they can start seeing, okay, how is the view from that unit? Like, so I see like there's no obstructions. I get like clear view on the right. Now I'm in the first person, because again, this is almost like a game, right? Game that I can start just walking around some of these units. And we can also go to the interior and see how that looks and start walking through. So with Unreal Engine, like there's the ray tracing technology, so we can start having real-time lighting on the interior. And then once the unit, let's say Jeff is satisfied with this unit, we can download that summary, and then it shows it already down.
Uh-oh. Looks like we lost Cesar. I'll see if he comes back. I was checking out in the chat while it's loading. Stefan Pinedu, look at that. Nice last name, dude. Asking if he's using Revit with Twinmotion. We can ask when he comes back. That was definitely Twinmotion on the initial animations, and then the configurator was is in Unreal, which there is a oops, sorry guys. Let me just go to the 2K screen. We're gonna have to link them back in. Hopefully, Cesar has no problems joining us again. The configurator is running on the web using Unreal Engine as the background, which I'll have to ask. But there is a connector. There's a bridge between Twinmotion and Unreal, and so you don't necessarily have to lose everything that you did in those initial renderings and animations, as you saw there. Check it out. Let's see. I was checking out the chat while we wait for hopefully Cesar to come back. I'm wondering if I would think that maybe the Unreal thing broke it, but he said it was running on a local service, so maybe not. So it's actually it's a Zoom call that him and I are on, so definitely something to do with potentially the Zoom call. So let me just keep checking out on here. Unreal 4, Unreal 5. I'll ask him. I would imagine it's Unreal 4 as well, considering how new Unreal 5 is. But I'm not gonna speak for Cesar when as well as that is concerned. Enscape. Mark P said Enscape kidnapped him. Maybe that is the case. And so let's see. I'm also gonna quickly double check my text messages and make sure. See if we can get him back in here. Apologize for that, guys. Pretty cool stuff, though, huh? I have a lot of questions that I can't wait to ask him when he comes back. I'm sure you guys too. So don't forget to ask away in the chat here. My guy is playing Sims in real life. Yes, it is very much like Sims. Yep, I don't see where he went, so I'm just going to chat with you guys. So feel free to ask some questions in here, guys. I guess we'll we could always do it. Ask me anything for a minute before Cesar comes back. Which software does he use for parametric design? It's a great question. I will definitely ask that when he gets back. The nice thing about what Cesar was saying is his group, he likes to say they're software agnostic. So I bet the answer would probably be whatever software was best or whatever tool was best for whatever it is that he was trying to do. Let me just check this here. Nope, still no. He must have he's reconnecting now. His computer itself actually crashed. Lovely. Awesome. Here we go. Hey, there he is.
Hey, sorry for that one.
No problem at all, man. I'm pretty good at killing time, I think, guys. Right? We had some questions in the chat and whatnot, so no problem at all. Whenever you're ready, you can share your screen and I'll tweak everything up on this end again and.
Absolutely, we'll yeah. I think the computer
don't worry,
didn't
no one left. Everyone's still here, so you must be really intriguing them. So that's good.
that's great. Yeah, happy to engage in further conversations with you guys. Let's see. I'm just kind of starting up the. Yep. No problem. I think it didn't like it, like the streaming and like all the pressure that computer just.
You know what's funny though? Actually, I've had some issues with Zoom and different resolution monitors. If I'm doing like something heavy graphics, I've had issues myself. All right, awesome. Looks like we're back up. And actually, you know what? Since we had a little pause moment there, I guess I could ask you. There's a couple easy questions that you could probably answer for us.
Yeah.
Somebody asked, are you using Unreal 4 or 5 for that configurator?
So for that, Unreal Engine 4. So pretty excited to now take it to the 5, which we have like ray tracing and Lumen is part of it. So it's gonna look much sharper on UE5 for sure.
And that the path tracing and ray tracing, that will carry over to your web version of your configurator. That all gets baked in.
So it's not, that's what's interesting. It's not, none of these, it's actually baked. So everything is real time, ray traced. And in UE5, there's Lumen. So if we start adding some lights, and I can show you later some videos that we have been working on UE5, the quality is just really great. So configurators and all these technologies where we can start engaging clients as we go, as we kind of encode those rules and make it dynamic. It's really powerful. So we're really excited.
Yeah. And so then the last question before we jump back into it that I think is a great one is, there was a couple questions about, what tools were used on the modeling front. And so, Grasshopper, or sorry, was it Rhino, Grasshopper, Revit, whatever, how are you setting up the initial models, parametric models?
We do most of the modeling in Maya.
Okay.
So everything is broken down into parts, but then we use a lot of Rhino and Grasshopper.
For the parametric aspect of it.
The parametric aspects, exactly. So we try to keep it as well a little bit agnostic. So we work a lot with JSON formats. I can show you a little bit on how we can break all these parts into JSON. So that way we can export everything and then call it in the configurator. But also we have been deploying like workflows to export it to Revit. So whatever. I mean, since when we're working with kit of parts, it's quite easy in a way that we're working with transformation matrices. So in that sense, what we need to just export is data, of transform information, and then we can reconstruct all of the users are playing out. We can reconstruct it based on CAD software. Call it Revit, AutoCAD.
That's awesome. That's cool. So you're using the JSON almost like an IFC in that sense, where you're pulling it down and then you can wrap it in whatever you need in whatever software it is. Super cool.
Exactly. And we're also trying to explore a little bit more now on USD and GLTF, because they have a little bit more of scene descriptions out of it. Then we could use web browsers to plug it in. So awesome. It's quite exciting.
Awesome. All right, sweet. So we made my unit, and now you're running through a little summary. Here.
So exactly after we did the configurator, we downloaded our order, and then this is a brochure that it's completely tailored to what the user said, right? Like it's going to be on the level 5 of the stack. It's a wide unit. It's have 225 square meters. And then which air rights did you bought, and then how many bedrooms, bathrooms are on that specific unit that was customized. So there's some information of the local side that the developer kind of wanted to also engage with, and then some kind of conceptual images of that unit, of how it would look into the interior and the floor plan. So it's a little bit tailored, and then what we get from out of this is basically we get this is like the data that we get, right? Like, so these are different configurations run through different users, and all of this information is also encoded. So it's a wide, a single, and then all the, let's say, like the transformation matrix and the position, rotation of that unit. So with this information, we can reconstruct it and bring it back to any other software model, basically. So even when we start breaking down a unit, so this is what I can start sharing also like these, just to understand how it looks like. So these are all the kit of parts that we model. And then based on that, they're getting swapped. So if you want a large terrace, if you want a roof, and all of that is being kind of deployed on the system, then this is a little bit of that information. And then this is kind of like the USDA now format that we're currently exploring is like, okay, so from one unit that we model, and then this is like the computational representation of that unit in space. So the configurator knows in the back end that if it has a yellow color, it will deploy it as a wood texture. If it has it as a blue color, it will give it more like as a thatched roof texture, and then glaze and cyan. So with these kind of computational data, we can start reconstructing everything. We can take it to the configurator, but that's what we're also exported back to a Revit a Rhino, and then continue refining it from there for structural engineering and whatnot.
Mm-hmm. Awesome.
So this is a little bit of how it's kind of like going into RAP. And then of course we can also configure interiors. So that's also something that we can deploy as parts, as modules. We tend to design everything component based, so that can be hosted in a voxel grid. So if you can have like multiple interiors for a wide unit, what are those configurations? Mm-hmm. And then of course, like all of these made available in Unreal, ray traced. This is a little bit of the configuration in place. We try to make sure that, I mean, we're architects, but mm-hmm. we're not experts in UI design, but it's something important. How do we present all of let's say all of the data in a UI friendly format?
Right.
And yeah, so real-time ray tracing. Some of these videos are not actually playing right now, but
no, that's awesome.
Yeah, this is a little bit on how our work flows.
No, that's great. So no, it's an interesting approach in the sense that I mean, at least in my mind, I'm sort of connecting all these dots of how this sort of not necessarily modifies, but it does, it changes the typical process. So I guess as an architect, I'm sitting there thinking, this is a really cool idea in a way, obviously a space like this that I think you can probably enforce more rules initially on, is a simple example of it, right? Obviously, the more customized the building gets, I think the harder something like this is. But I guess, so then my question on the back end, I guess the design process to sort of set up these rules, what did that look like for you guys? You obviously have to bake a lot of rules into this configurator. And so, was that something where that was mostly the architects, the design team themselves saying, these are the rules we want to bake in based on, the typical design process. And then now let's hand it over to the users and say, how do they start interacting now that we've given them these rules? Is that kind of the thought process?
Exactly. Just like that, Jeff. So as you were mentioning, I mean, we're interested in having like feasible and curated designs as outcomes. Mm-hmm. So for example, we can encode like the voxel base is intelligent enough that it could say, okay, if we put a wide unit cannot be on top of only one single unit, or how much you can't deliver from the unit that is below you. So all those kind of rules we need to encode as well in the process. Then if there's some clashes, it won't allow you to do that. Mm-hmm. So all of that design intention, how we in a stack, for example, in this type of units are made of wood and are crafted. So one of the things that we kind of take seriously as well is how do we manufacture some of these pieces, right? So we have a kit of parts, and then everything is kind of deployed on locally using like small machines, because it's kind of a remote access. Mm-hmm. So everything has to be broken down into those parts. So the same way that this is going to get built, we also need to encode those rules in the design process and the configurator to allow like that feasibility at that feasibility stage, right? And also like with local suppliers, how much material does it take out? And then we can register, since it's a kit of parts, it's kind of like a platform approach, right?
Right.
And then we can break down all of those elements, and it's kind of like a little custom beam. Mm-hmm. Because then you can start saying, okay, in this aggregation, in this configuration, how much is actually going to cost? How much time is going to take? Because we can extract all that information out immediately from those plays. Mm-hmm. So it's taking a little bit of all the ideas of that you see like maybe in the scenes and those games, and then try to bring it to life in actual projects. So that's what it's kind of exciting for us to kind of engage with.
Definitely. So on the on the, this is definitely a semi prefabricated, semi site assembled, right? It seems, kit of parts, like you're saying. So I have to imagine that in this process, you're engaging the construction end of it pretty early, right? I would imagine. It sounds like, you're trying to build a lot of this information into the configurator, even on the pre-construction early design side of it, so that in theory, once these things are picked by the clients, it's, there's not, I'm not saying there's not much more work to do, but like, you've kind of figured out, all of the solutions or the results of their configurations, and then you're just kind of now, okay, here's the parts, here's how we make that unit, and so on.
Exactly. So we are dealing with a company called Circular Factory that is kind of getting now in that place in the island in Roatan. And then they're bringing now some robots. So all of these parts are going to be custom fabricated, with the use of robots, just to cut all those curves and preparing all the parts for the deployment. So ideally, this platform or this configurator can be connected to their database in a way, saying, okay, we received this order. So that way they can already start processing orders based on actual configuration from users. And one of the interesting thing about this is that is also the community part, right? Because virtually, I mean, if you kind of run the configurator again, and then I'm gonna enter again now as for example as myself, and then I'm gonna log in. So when I get back into the configurator, I know that, so that's Jeff's unit. It's, you already placed it there. I want to be next to him, so I'm gonna say, okay, I'm gonna select that unit, and then you can start customizing and creating that community and getting to know your neighbors. So let's say we want to just be kind of next, and I'm gonna pull like a tall unit to showcase a little bit of how that kind of looks. And actually, you know what? I'm gonna also select, when I select the air rights from the top, then I can have an option to get a palapa, which is like these vaulted roof. So now if I select that vaulted roof, like the system is good enough, it knows enough, like if it knows that there's a unit above you, you cannot place a palapa. But if you didn't buy the air rights, you can also you're not able to place that roof, right? So that's the thing of how do we encode those rules architecturally, that we can make sure that we have, like peaceful designs and allow the user to configure and make them part of the process. So again, we can just enter and start selecting different type of layouts. So this is what I'm gonna go. I think I'm gonna go with this one and go back again. And then you have like a completely different unit now. We can just kind of run, and then we can just kind of come up in space. So you can start seeing how that space looks like. This initially from a double height. You can just walk and see how it goes. So yeah, it's a little bit, it's trying to be like it's a first pilot project, just to understand what are the, like the concerns and how we get it. Of course, like there's, in this way, we have also realized there's some engineering constraints. That's a little bit of every time we do a change, sometimes, this needs to get re-engineered. So how can we encode those rules at the early stage, the beginning, so we make sure that all those outputs are feasible and available for construction immediately.
Awesome. I love this, and the community idea is fascinating because what you just showed there, right? If I'm Jeff who built that first, the first unit, and then you come in and build this 2-story monster on the east of my view, then you maybe you're hashing out some of these issues early, which is I guess from the developer or the owner standpoint is probably great too. So
I know, and it's interesting to see the game theory around it, right? Like, because a lot of in these sessions with potential buyers, it's super nice to see like the dynamics and who's actually there, and then they say, no, I don't want to be next to that person. I know he's gonna throw some parties, so I'm gonna go maybe to the other cluster. I'm gonna be a bit more quiet, and then it plays out, because maybe you would think that the first one is the most privileged one because you have like hey, I can go to the top of that unit, but as you said,
Right.
like, oh, then I can put the unit up beside you and then block the view. So
Right.
sometimes like the last person might not have like the best spot, but he can choose between all the options just to make like the best decision out of it. So the game
Right.
theory out of it is also quite interesting, like that gamification.
Yeah. Yeah. That's awesome.
Yeah.
So tying this now back to sort of the initial, this sort of initial theme of, this gamification, this using these tools, and then sort of, okay, now reality, we got to build it. I'm looking at this and the architect and the contractor, both sides of me are just sort of talking to each other, and I'm sort of thinking, so building all these rules and parameters within this system, the configurator, is one thing, but then building it and documenting in that process, are you, when you're building these configurators, do you already have the manufacturing side of every variation and version ready to go, or is it you wait till it's baked and then now let's look at it holistically and figure out, okay, now we need to produce a manufactured level model or drawing or CAD file, whatever, right, from there? Or are you kind of ahead of time saying, here's our 6,000 options and here's 6,000 ways to build each of these options, and then when they pick it, build it, that type of thing?
Yeah, that's a great question.
You see where I'm going with it, right?
Yeah, because it could be like a real pain, like it could be complexifying a lot of process, but so ideally not all the details are there. I mean, eventually that's where we want to be, right? Saying like, okay, whatever you choose, and then the configuration, 100%. Like, I don't know if in the states is the same, but like those 5 stages of construction, for example, in this way, we can guarantee that around stage 3, which is that schematic design, we have it already kind of set out. So on this level, we can and again, it's a kit of parts, right? And then depending on the rules, if those kit of parts, you could draw them and specifying at that construction level, then it's almost ready to go. It's just how is that interface with the other unit that's going to change a little bit. But most of the details is kind of building a car, right? A car has like the same components all the time, and then maybe you're changing a seat with another leather, or another shape, but the details of connections are going to be always the same. So it's kind of how can we approach that construction process in a different, thinking more as a platform approach as that kit of parts, which is quite interesting.
No, I love that. And that's kind of where I was getting at, and I'm interested because I don't know right now where you are in this process, if this is where it's now, or if you've moved on. But I'm interested in sort of when you look at this, like, like you said, the interaction now between all of these units, which are all kits of parts. What is your, either how do you plan on, or what have you done so far to sort of, okay, take this now configured building and produce something for construction from it, permits, whatever, you name it, or whatever's needed, like, or maybe just start detailing the interaction between them. Have you thought about, I'm sure you have thought about it, or maybe you've done it, what does that look like, taking the most efficient way to take this now and convert it to a holistic model, let's say?
Yeah, so we have already the parts.
Okay.
Right. And then we have the transformation data of all of these components in this place. So we can bring all of this already to Revit, to Rhino, just to keep it developing it. So that then once we have it in a CAD software, now we can start really finding those connections, specifying, okay, do we need a plinth underneath this unit? How long is going to be the plinth? All the structure to support it. So this gets us, as long as we can get here on a 50% level, that whatever we set out, then it already makes our life easier as architects, just to say, okay, we need to remodel this again. We just take it then on that next level, which is that construction, like the design development stage, stage 4 in here in for example, in the UK, that's how it's called. So yeah, in that sense, I mean, it's kind of a work in progress, of course. I mean, ideally we can get more and more details as we go, as we play out these configurations and encode most of those rules in real time. So that way we can even get drawings and documentation out of it. But most importantly, I mean, it's because it's not really about, in this case, getting the drawings, right? Like if we can connect this database directly to the manufacturer, we can really almost jump a gap, saying, okay, because we're dealing now with data and component parts that are going to be just referenced in the geolocation on a specific moment.
Right.
So that way, we can kind of think it a little bit more agnostic of a traditional process.
Mm-hmm. Mm-hmm.
So that's why this is like a test pilot in this island where they're setting up like these. So the developers are part of it. It's called Prospera in Honduras. So they have this land which it's under a development called like a sede. Okay. So they are able to adjust zonification rules to kind of how they want to plan it. In this case, they act almost as a government, like a developer government. So in that sense, it's interesting seeing how can we systematize this grid and make sure that those rules, we might not even go through all the stages of design and have all the documents ready, but we just need that data available in order to start and get it built.
Right.
So
yeah, and I think, I mean, looking at it, and that's kind of why I asked the question, is if these units weren't touching each other, for example, it sounds like you probably could, configure, and then, if the kit of parts stays the same, you're building from that kit of parts. It's an interaction with each other and the contextual interactions that I think that where I'm thinking in my mind, okay, you put this all together, but it's like you got a detail here where this wall's touching this wall. That's not a kit of parts anymore, right? It's something a little more. So no, that's really neat.
That's very true. But you could also, for example, take it as because eventually these are kit of parts, but are voxel based, right? So a voxel, when you put a voxel with another voxel, if you can specify, you can tell the rule that if it's open, do a detail, and if it's closed and it's touching to another, make another detail.
Right. Yeah.
So that way you can still kind of apply the same rules in some sense.
In some sense, yeah. So then that kit is just the joint.
Exactly.
Yeah. Of course, that means you'd have to build all those joints into the configurator.
True.
The more rules, the more stuff that you're building in the configurator, right?
Exactly.
There was a question a while back, and I think it got buried a little, but I was interested too in so you show those initial visualization in Twinmotion. I would imagine once this is in Unreal, then you can technically do all the visualization in Unreal. Have you played with the bridge between the two, as in, because in my mind the process makes sense in the way you're showing it, in that maybe the Unreal folks don't need to touch it at that really early conceptual design phase, and that's the visual design team, all that good stuff. So maybe they're using Twinmotion. It would be a shame to dump it all. Have you used the bridge to sort of pull it in for this aspect now?
Exactly. Okay. Yeah, because that's we try not to repeat work again, right? Like, so for example, whatever it's set up in a Twinmotion as a scene, we can export it and bring it back to Unreal directly through the direct link. Okay. So the scene that we highlighted at the beginning, saying, okay, this is a scene that we want, and then we start systematizing. We break down everything into parts, but that environment is going to live on, and that configurator, or call it digital twin afterwards, like this property can get developed. So that early design process, just to set out and interging like a scene in Twinmotion, it's really powerful.
Mm-hmm. That's awesome. Yeah. And so I'm looking at this configurator, and I'm just asking questions. I have a bunch, but I'll keep an eye on the chat. So if you guys have any questions, make sure you ask them in the chat there. I think I hit most of the ones that were sitting there. So I'm looking at this configurator, and all of the interactions, all of the UI, and was that all built in Unreal too, or you had to sort of mix and mingle?
So that it mix and mangle, yeah. So because the problem is, like, all of this technology, in order to run it on the web, it's pixel streams, right? So it's not running on a client as a normal browser does. So this on the deployment level, it was hosted on AWS, so that way you get only the pixels. But when you do the interface there, you get quite a lag because you click, let's say, on the screen, and then that connects to an AWS server. and then there's some latency on that response, which is not ideal. So
Right.
these, it has to be done in front end. So using HTML, JavaScript, normal CSS, like normal
Okay.
Web 2 developments. Yeah. So all
Got
the
it.
front end is there, and then it's communicated to the application that it's posted on AWS.
Got it. No, it's neat. Yeah, because I mean, I have seen some Unreal stuff where you could build some of this into it, but that's why I was interested on the web-based side of it. So you're creating a UI on the front end that's then attaching to the back end. Awesome.
Exactly.
Awesome. A couple. Let me just make sure I hit all the questions here while we're going along. There's a couple of people that were asking about Grasshopper and parametric, and it sounds like you did explain that. So it was interesting. So I'm interested then. Why did you guys choose Maya over, let's say, Rhino for the initial sort of modeling?
On the modeling, I mean, we tend to work. I mean, it's not that we don't use Grasshopper and Rhino. I mean, I think I use it daily, like all the time. Even nowadays, even more than Maya. So that's why we try to keep it like a bit of agnostic. We can do very, very fast sketches and models in Maya that will take a little bit longer just to process and deploy all the parametricism in Grasshopper. So normally the workflow is try to model fast, iterate, do a lot of options, and then refine them. Once we have, like the feel that we want for that design, now it's time to rationalize it and bring it into Rhino and Grasshopper usually. So we're getting mostly interested in trying to remove like the NURBS workflow. We try to work mostly with discrete elements, with meshes, because it's computational. It's really, it's much faster. Although there's some limitations on manufacture-wise that we need the precision of the NURBS in that sense, or let's say we need to have arcs, and then there are ways that you can start getting perfect arcs with meshes, but it's a little bit more convoluted as a process. So yeah, we try to mix them a little bit, but that further stage, let's say like the first concept design, we do it in Maya very, very fast, because the polygon modeling, it's quite straightforward. It's quite fast to work with.
Right.
And then in Rhino, we just rationalize all those components to make it manufacture ready.
No, it's a great point. I wasn't even thinking that the difference between polygon meshes and NURBS, especially when it comes to the the manufacturing of it, like you said. The if you get down to the nth degree of some of these components, you don't want to have a segmented polygon mesh, right? To if you're building a kit of parts. Awesome, cool. All right, so unless there's anything, is there anything else you wanted to show while we had a little bit of time?
We can go, because some of the things that is starting to get exciting, and like our next so these are like our basically our next iterations are on metaverses, right? Like, so how can we make this available? I can show these this little screen. Unfortunately, I think this video, but it's not really playing out at the moment for some reason. I don't like it. So basically, this is a project that we're been developing for Liverland, and then also all of this kind of the having this also metaverse ready is quite interesting. And how can we combine it, right? Because then we can start having a digital twin that people can configure properties, and then how can we have a manufacturing process on the back end that can construct that, but I could also live and create communities on this metaverse digital twin world. So that's also some of the things that we're kind of exploring a little bit further. I think I have some other, fortunately, some of these videos, classic, right? It's not playing when you need them.
Yeah.
To play.
PowerPoint is really good at that.
Yeah, exactly. But anyway, just having these ready also for metaverses, and it's also something that it's really exciting for us. How can we start mixing user participation, user experience design, not only with real with real component, but how can we have like that digital twin aspect where we can iterate and get feedback fast from that digital world and then bring it to life. So that's where we're starting to, get more and more these metaverse like projects, and we can test it, right? So because once you do it in real life, that's it. And then you
Right.
have all the critics and afterwards. But if you can test it into a digital world, metaverse,
Right.
so you're gonna say, oh, this is a problem here. People are actually traversing here, and then spatially it's not as nice as it would look. So we can, without any cost, iterate through it, and then we can, from those learners, then we can make our buildings for the real world better. So it's kind of like an informed decision between metaverses and real life. It's quite exciting.
Yeah,
We're starting to.
that's a fascinating point. I always, the initial thoughts of metaverse is building within that environment and living in that environment and sort of, for that environment. But now that you sort of mentioned that, it's an interesting thought that you could live in the metaverse version of your unit for a couple days even, right?
Exactly.
And you're still, the end goal is still building a physical object, but you're using this concept to live in your unit and then, give the feedback before anyone even builds it. And that's fascinating. To me, I always thought the end goal was the virtual object, right? But when you think about it, now you're using this concept to actually affect the physical environment, which is pretty neat. That's a super neat idea.
Yeah.
Cool.
I mean,
awesome.
We can iterate faster, and it's exciting.
No,
Understand what
cool.
people like and trends and everything. You can feedback our designs with that.
I love it, man. Awesome. Well, I think what I think we should do is I think once this progresses forward and you start getting further onto this project, maybe we'll have you back on to let us know how you decided to convert this into physical buildings and what the process looked like, because I think people will probably be super interested in that. So we'll have to stay in touch.
Hard for that.
Yeah, we'll have to stay in touch, and I look forward to for the first email of a unit coming in place on the crane, and then we'll set up a call, all right?
Yes, absolutely, Jeff. Definitely.
Is there anywhere that people can find you, contact you? What's the best bet?
I think through normal social media, LinkedIn would be kind of like the easier.
So I'll make sure to put a link in the description here after the video, so everyone can click and follow along and reach out if they need to. Any final words before we wrap up?
Well, thank you very much for the invitation. Sorry for the technical issue at the middle, but
it wasn't too bad. It wasn't too bad. It's a live show, right? It's a live show. It's all good.
Thank you so much again, and everyone for being here, and glad to extend the conversation. So don't be a stranger, just reach out.
Awesome. One last question someone had before we head off. He said, can this approach ever be fully open source?
I guess so, in a way, like that's what's also interesting in a sense. I think it should be in a way. So
in some way it is, right? It's just a matter of how you make it. But yeah, I guess they're probably asking, can you share this? And we'll as it unfolds, we'll figure out how that plans. But exactly. I appreciate you sharing the approach and the process with us today, man. It's super exciting. It used a different part of my brain I haven't used in a while, so I appreciate that, and I hope everyone else there feels the same. So
I know it might be sometimes like this is because it became kind of like my day-to-day process, but I can imagine, like at the beginning when trying to think about this, is like, okay, this just sounds crazy, and then and I respect that, in a way, I guess, but it's trying to think, some of the status quo, rethink a little bit of how we do stuff and how can we make it better for the future.
Yep, 100%.
So
I am all about figuring out how to change processes that we all know are archaic and outdated to look towards the future. So I appreciate that, Cesar. It's awesome content. I appreciate you so much, Jeff. You being on today, and for everyone who's here, thank you for sticking around for the couple minutes that we had some technical glitches. I think we worked through that, and thank you guys for joining me. We've got another episode next week. The replay of this will be live right here on YouTube, as well as on at bimafterdark.com. I'll make sure to put all the links in the descriptions below, and I'll see you guys all next week. And thank you again to Twinmotion for sponsoring this episode. Again, head on over to twinmotion.com/bimafterdark. Let them know that you support this channel, and see you guys soon.